Hello, you are welcome back. All right, so we've actually talked about the relationship between frictional force and, of course, the coefficient of frictional force. From the formula, we have that frictional force is equal to coefficient of frictional force multiplied by monomer reaction. I would say that this coefficient of frictional force can be divided into the coefficient of static frictional force or the coefficient of kinetic frictional force. So in this video, we're going to look at how to determine the coefficient of static frictional force in two surfaces. We have the horizontal surface and we have the inclined plane. Now this is a horizontal surface. Now on this surface, I have a mass m1 that is actually connected to another mass m2 via a frictionless pulley. All right. Okay. So now what is the whole idea? The whole idea of connecting the mass M2 to this mass M1 is to actually create a tension on this rope or string in order to pull this mass M1. Now, because there is a force that is acting on this mass, which of course is frictional force, we are made to understand that from what we actually understand about static frictional force, this particular mass is at rest. Why? Because the frictional force that is actually acting, the frictional force on this particular mass, all right, is equal to the tension that is actually on it. So invariably, then we can say that this mass is at equilibrium. There's no movement because of this is static frictional force. All right. Remember, static frictional force, the masses are at equilibrium. So the net force, okay, is equal to 0 because it is static. There's no motion. The net force is equal to 0. So how do we calculate the net force? The net force is going to be equal to the tension that is pulling the mass m1, then minus the frictional force Fr, which of course is equal to 0. So we can simply have that the tension is equal to the frictional force. All right. So now how do we calculate the tension? The tension on this particular rope is equal to the weight of the mass that is pulling on it. Okay. So invariably the tension on this rope is equal to the weight. Sorry, it's equal to the weight W2 of the mass of this particular mass that's pulling on the rope. All right. So let's do that. So the tension is equal to the weight W2, and W2 is equal to M2 then multiplied by the acceleration into gravity. So that is m2g. Then frictional force, we know that frictional force is equal to mu, in this case coefficient of static frictional force, mu x. All right, then multiplied by normal reaction. Okay, so normal reaction. And what is normal reaction? I told you that the normal reaction on a surface is always equal to the weight, okay, of the mass on the surface, because the normal reaction, okay, is such that it will withstand the weight on the surface. So invariably the normal reaction of this surface is equal to the weight of this particular mass on the surface. So let's bring it here. So invariably now we have that m2g is equal to the coefficient of static friction multiplied by the normal reaction, which of course is m1g. So what is the whole idea? The whole idea is we are looking for the expression for the coefficient of static frictional force. So the coefficient of static frictional force mu x is going to be equal to m2g then all over m1g. So g cancels g, so we're going to have m2 all over m1. Okay, so anytime you see such a diagram, all right, of a horizontal surface and you're being asked to evaluate or to write the expression for the coefficient of static frictional force, all right, the coefficient of static frictional force, we have it m2 all over m1. M2 is the mass of the object that is pulling the mass on the surface. All right, so please take note of that. So this is for a horizontal surface. Now let's look at let's consider an inclined plane. Or you call it an inclined surface. All right, inclined plane or surface. All right. So let's see how. Okay. Let's look at that. So let me draw an inclined plane. Of course, an inclined plane is a plane that is inclined at an angle. So it is a plane that is inclined at an angle. It's not horizontal, but rather it is inclined at an angle. So here we go. All right, so let me just draw. Here we go. So let's say we have this mass. Okay, M on this inclined plane. All right. So without me trying to pull on this mass, ordinarily by actually raising this plane to incline at an angle theta, okay, there's always going to be a force, all right, due to the potential, okay, due to the potential of the plane, because the potential have been created by raising this plane, all right, and of course inclining it at this angle. So that potential is going to supposed to create a force, okay, in which if that potential is large enough, then freely this mass is supposed to slide down the plane. So there's a force, all right, that is based on gravity, okay, that tends to slide down this mass downward. And I don't want to go through the derivation of how we can derive that force that is parallel to the plane. The force that is parallel to the plane of any inclined plane is always given as mg sine theta. So please take note of that. Mg sine theta. So this is the force that is parallel to the plane. Anytime you see an inclined plane, okay, and you want to evaluate or want to write down the expression for the force that is parallel to the plane, all right, the force that is parallel to the plane that is based on the weight of that particular mass on the plane is given as mg sine theta, okay, or w sine theta, depending on what you're looking at. Of course, you know very well that w is equal to weight is given as mass times acceleration into gravity. Okay, so please take note of that. So invariably for this inclined plane, this object should be sliding down, okay, but something is going to withstand the downward movement of this mass, and that definitely is going to be frictional force. So frictional force will definitely act in opposite direction to the movement. Okay, so now because we are actually discussing static frictional force, okay, we know that in static frictional force the net force on that mass is equal to 0 because there is no motion. The reason being that the object, all right, or that particular object is at equilibrium. There's no motion. Okay, so please take note of that. So how do we calculate the net force? These two forces are acting in opposite direction. The net force is calculated by subtracting. So that's going to be mg sine theta, the force that tend to slide this mass downward, minus the force that is opposing it, which of course is frictional force, Fr, is equal to 0. Can we proceed? Yes, we can proceed. So here I'm having mg sine theta. Mg sine theta is equal to frictional force. Frictional force, take it to the other side, that's going to be frictional force. Now the question is, what is frictional force? Frictional force, we know that it is mu normal reaction. Okay, so in this case, how do we express the normal reaction? Because as you can see, this surface is inclined and at an angle. This is not like a horizontal surface in which the weight is directly downward, and the normal reaction is also opposite to the weight. Okay, the surface is inclined, so the normal reaction will be inclined at an angle. So the normal reaction is not downward, because the normal reaction is going to be normal. All right, it's going to be perpendicular to the surface. Don't forget, normal reaction is always perpendicular to the surface. So if I want to draw the diagram, okay, so this is how the normal reaction will be. And as you can see, the normal reaction, okay, is not vertically downward, but rather this normal reaction is inclined at an angle. All right, so as I said, I don't want to go through the process of resolving vectors. So for the case of inclined plane, the normal reaction, okay, is not mg. Unlike what we have here, the normal reaction is equal to the weight of this mass, mg. But rather, in the case of an inclined plane, all right, the normal reaction rather is mg then cos theta. So please take note of that. Normal reaction of an inclined plane is mg cos theta. Mg cos theta. So normal reaction is mg cos theta. So let's bring it here. Okay, so we are going to bring it to this expression because the whole idea is for us to find the coefficient of static frictional force. So I have that mg sine theta is equal to the normal reaction, the frictional force, which of course is coefficient of static frictional force mu x multiplied by the normal reaction, which of course is mg cos theta. All right. So let's the whole idea right here is to make mu x the subject. So mu x is going to be equal to mg sine theta divided by mg cos theta. Of course, mg cancels mg, so we are left with sine theta all over cos theta. So for an inclined plane, all right, the coefficient of static friction is calculated by the formula m sine theta over cos theta is always tan theta. That is tan theta. So please take note of that. The coefficient of static frictional force, all right, in an inclined plane, a plane that is inclined at an angle, is mg, is tan theta. All right. So of course, if you let's look at the typical examples. Okay, so if you have a plane inclined at an angle of 30 degrees, so you are being asked to calculate the coefficient of static friction, the normal reaction. Okay, so coefficient of static friction. Let's say we are being asked to calculate the coefficient of static friction, the normal reaction, okay, and of course the force that is parallel to the plane. Force parallel to the plane. Solution. Okay, so let's say this is the A part of the question. A, the coefficient of static frictional force simply is tan 30, and of course, let's say the mass on this plane is let's say it's 2 kg. All right. Tan 30, okay, mu s is tan 30. So we can do that. Okay, let's do that using special angle triangle. Okay, so this is 30, this is root 3, and this is 2, this is 1. So invariably tan 30 being opposite all over adjacent. Opposite of 30 is 1. Adjacent is root 3. So tan 30 is 1 all over root 3. So this is 1 all over root 3. So the next we have to calculate is the normal reaction. The normal reaction is mg cos theta. So that is going to be 2 times 10 approximately, which is 20, then cos 30. So this is going to be equal to 20 cos 30 is root 3 all over 2. Root 3 all over 2. So this is going to be, my answer now is going to be 2 root 3. 10 root 3, please pardon me. The answer is 10 root 3 Newton. Let's see the force that is parallel to the plane. That force parallel to the plane we know already in an inclined plane. The force parallel to the plane is mg sine theta. That's 20. Mg is 20. Then sine 30. Sine 30 is 0.5. 0.5 multiplied by 20, that is 10. 10 Newton. Okay? So please take note of this, and we are going to look at more in the next video. So see you in the next video. Thank you very much.